Alrighty, so we started to talk about end behavior of our polynomials. So when we have a positive leading coefficient and an odd degree, remember that other than outside of the middle of our graph, so if we are just thinking about what happens at the far, far left and the far, far right. So as we were going through all these, yeah, sometimes nonsense happens in the middle, but anything with an odd degree and a positive leading coefficient, so that would be like our linear functions and our pink ones. So they all start in the bottom left corner and end in the top right corner. That's not a coincidence. They will always, always be that way. So if they have a positive leading coefficient and an odd degree, our most basic example that we can think of is y equals x. So sometimes I go back to that, or even y equals x cubed, y equals x to the fifth. They're all going to start and end the same way. They're all going to start in the bottom left and end in the top right. Now, whatever happens in between, we honestly don't care about. All we care about is the very bottom left and the very top right. So as we move left and left and left and left, so as x approaches a negative infinity, our y-coordinates go down. So our y-coordinates are approaching negative infinity. As we're going farther to the right, our y-coordinates are going up. So as x approaches positive infinity to the right, f of x, or our y-coordinates, approach positive infinity. Now, what about our negative leading coefficient odd degrees? So these are our green graphs from the same degreed function. So 1, 3, 5, 7, 9, they're all going to be the same. So they're all going to start in the top left corner and end in the bottom right. So start in the top left, end in the bottom right, or sometimes I'll say start high, end low, right? So start in the second quadrant and so start in the second quadrant, end in the fourth. So our negative leading coefficient is always going to look exactly like our positive leading coefficient odd degree, but flipped upside down. So again, something's happening, probably, honestly, who cares, as long as we recognize that it starts in the top left, ends in the bottom right. So as x approaches positive infinity, we're going further and further to the left, our y-coordinates are going down. So our y-coordinates are approaching negative infinity. As we're going to the left, our y-coordinates are going up, so our y-coordinates are approaching positive infinity. Now for our even degree positive leading coefficient, these are like our y equals x squared, y equals x to the fourth, y equals x to the 16th, y equals x to the 45th. Nope, that is an odd number, not an even number. Good. So we just need to recognize that they all have even degrees, so even powers of x's. And again, remember that we're talking about the degree, which is the biggest exponent. We don't care about what the rest of our function looks like. All we care about is our greatest degree and our very first leading coefficient. So positive leading coefficient, even degree, those are like our y equals positive x squared and y equals positive x to the fourth. Notice that those both start high, end high. So I'll say these look like touchdowns, right? Both our arms would be up and up. So if they both end up going up, looking like that, no matter whether you're going to the left or to the right, your y-coordinates end up going up. So they will both be approaching positive infinity. With our negative leading coefficient, same idea. Those are like our upside down parabolas. And again, who knows what's happening in the middle? Maybe it's just a parabola. Maybe there's some bumps going on in there. If it's x to the fourth, who knows? All we care about, though, is that we start low, end low. So no matter whether we're going to the left or to the right, our y-coordinates are going down. They're approaching negative infinity. So no matter what polynomial we have, we can just look at whether the degree is odd or even, and whether the leading coefficient is positive or negative to determine what's going to happen with our graph. Which is why in example 4, we're able to say, oh, it starts with a negative leading coefficient, it has an even degree, so we expect it to look like our upside down parabolas, start low and end low.